Hello everyone. In this session, we are going to discuss about Kubernetes one more microservice APIs. Okay, Kubernetes APIs, which is services. Okay, first we will understand why services are required. Okay, so we will go through the lab scenario which we have done it in the previous session, where I have launched the replicas using deployment. When I have launched the replica using deployment, you can see it. 5 pods are running it. Okay, each pod is having a different IP. Each pod has its own pod name. When I'm launching through deployment, each replica pod is getting its own name, which is randomly generated, followed by the IP. Now, here, what is the point you should note it out down is that the pod name, when we are using deployment and the replica pod which is created, the name and IP of the pod is not static. They will change when the rescheduling happens. Okay, I'll just show you here. I'll go and delete this pod, delete pod, and this pod I will go and delete it out. And when it will be created, it ending it with the RVD. Let's go and see it again. There is a pod 4 seconds before it has created. You can see the pod IP is also changed, and the name of the pod is also changed it out. So this is the problem. So suppose you have two different set of application is there. One application is front end, which is running three replica pods. Okay, and each three replica pods has different IPs. Second is backend, which is running your DB kind of application or some kind of application which has to be connected. Front end wants to communicate to the backend. Now the IP or the name of the pod is not static. IP can also change or name also can change it. So in case of rescheduling, if the new pod is rescheduled, how the front end will know which are my backend pod, or even vice versa, how backend will know which are my front end pod, because pods by nature are stateless. Stateless means the IP and the name both are not static. Replicas will be, once it deleted or rescheduled, the name and the IP will change. Okay, so how the two application will communicate to each other, or even I am hosting some application in the pod format, or some outside world application want to reach it out, how they will reach it out, because the IP can change. How will they know where to communicate it? Okay, so here only Kubernetes launch one kind of API resource which is called services. Let's go and discuss about Kubernetes services, what exactly it is, and how it is going to help you out to address this kind of scenario. So Kubernetes services is an abstract way to expose an application running on set of pods as a network service. Kubernetes pods are created and destroyed to match the desired state, correct? Pods are non-permanent. Some pods called backend provides the functionality to other pods to do front end inside your cluster, how the front end will track or keep the IP address, or how they will connect it. So here only the first resource type which is going to address it here is service resource. In Kubernetes, a service is an abstraction which provide a logical set of pods, a policy by which to access them. Sometimes it's called microservice. A set of pods targeted by the service is usually determined by the selector. So here what exactly is going to happen is you can visualize this thing in this way that okay, if I am running a application multiple replicas, I will be a single application without containerization or without pod. Simply a application multiple copies are running it. We use a load balancer concept. Okay, through the load balancer, the traffic will be forwarded here. Similarly, now what exactly is going to happen? There is a service type resource will be created. This service type resource will be finding it out which are my pods where the traffic has to be forwarded. Okay, this service will be having a name as well as followed by the IP address. So this is a kind of a virtual IP address which is internal to the Kubernetes cluster. By default, service has multiple different type. Initially, that if I don't mention the type of the service, it is always a cluster type service which will be created. The IP which service is going to provide is the internal IP. So the pod can communicate to the service, and the service through it will go to the respective pods, okay, which is the endpoint. Here we will be using one more term called endpoints. Endpoints are nothing but the IP address of your pod. Okay, so we will be forwarding your traffic to your pods. Okay, now here you can see it. I'm running 5 replicas here. Okay, so this is my 5 replica. I just show you get pods hyphen show labels. So 5 pods are running it. Each pod has the replica label app engine X. Okay. Now what I will do it, I will go and create the service type resource. I'll just go through service type resource. This is the name of the service. Okay. This is sorry, this is a kind of the service. This is the name of the service. Currently, I am running in the default namespace. I will remove the namespace. App colon I need to give engine X. Okay. Here you can see it. I have not mentioned the type of the service, so it is by default cluster IP type of service. The port where service will be listening, target port, the port where container would be listening. Basically, in the pod, you're running a container, and that container will be running some kind of application. So, where exactly that application will be listening, that is the target port. Now, I'll go and create the service. Get first, I'll show you the service. Okay, I'll go and delete all the services so confusion will be not there. I'll just go and delete the old services which I have created it. So I'll just go and create it now. Create. Mostly services I deleted it out. Okay. Now what I will do is I'll go and create the service type resource kubectl create hyphen f svc dot yaml. I'll just moment I create it, you'll see that okay, there is a service type resource is created. I'll just run the command kubectl get svc, and you will see that okay, service type resource is created. Type is cluster IP. There is a name is created. Service is listening on port 80, 8 seconds before it is created. Now I told one more thing that service will be mapping to your pod IP address. So here there is one more command comes kubectl get EP. EP stand for endpoint. Here will be the name of the service, and these are the IP address of your pod. These are the IP address of your pod. How will you see it? Your IP address. You will run the command kubectl get pod hyphen oy. You will see 204, 205, 207. So all are the IP address of your pod. So how the scenario will look like now? You will be forwarding the traffic to your service. Okay, through the service, it is going to the pod, pod IP address. So service is just a logical entity which is sitting in between to send the traffic. In case a pod is added or deleted, automatically service will find it out that which are the newly added pod or which are removed. This whole process is called service discovery. What is service discovery? A service discovery is a process where service uh, and controllers will be running using the selector. They will be finding it out which are the pods are having the same label and automatically update the endpoint table. They will keep on adding the endpoint table. So here you can see it. This is my endpoint table. Currently this endpoint table is showing 5 replicas, which you can see it. I can go and edit my deployment. I'll just go and edit my deployment, get deploy kubectl edit deployment. I just do it. Okay, and show you that if I go and remove the replicas, how what will happen. So I just go and remove the replica. Currently it is 5. I'll make it 2. Automatically endpoint table will be updated. You see it's showing 2 only. So this is the concept of service discovery. Again, I will repeat, service discovery is a process where service controller, which is the part of Kubernetes API, a controller manager, which will go and use the selector value, which is under the svc service.yaml file, and run the scan on the worker node and find which pods are running with the same label. So the pod level, if it matches, automatically service will go and update the endpoint table. Okay, that this table will be updated automatically. And this process is keep on running process. So automatically this will be running it. So couple of topics we learn in this topic, in this chapter. First, why services are required, what services are doing it, what is the default type of services, what is service discovery process. I will be adding the lab session here as well end of the session. Thanks for joining. And let's connect to the next session where we will discuss more detailing about the services, what is node port type service, what is load balancer type service, everything. Thank you.